All right, here we go. Okay, so this is the 2-1. So we're doing the parallel stuff. Okay, so it says Jody draws parallel lines P and Q. She sets up a figure as shown to prove that the lines must have the same slope. First, she proves that triangle JKL. So let's just say, look at where she's looking. JKL is congruent to RST. By angle, side, angle. Okay, what should she do to complete the proof? So how can we say that these two triangles are parallel? Or those two lines are parallel? Okay, so if we say, if anytime you hear the word parallel, what should you be thinking about?
Same
slope. The slope. It is always talking about the slope. So we need to figure out what the slope is. Okay, how do you find slope? Slope is what over what? Rise over run. Okay, so if you're thinking about line P, how are we going to find the rise over the run? What sides are we going to use? Yes, Asia?
JL, yeah.
Okay, good. So the first thing that we want to say is that we're going to first make a statement that the side KL is congruent to ST. So those two lengths are exactly the same, true? Okay, because the triangles are the same. And JL is the same as RT. Okay, so since that's true, then the slope of P, okay, what's the slope of P? Good, so the slope of P, I'm going to say the M of line P, forgot my E. Line P is KL over JL, which is equal to what? ST over RT. Okay, so since they have the same slopes, then they are parallel. Okay. Everybody okay on that proof? Does that make sense to everybody?
Right.
Yes.
Are we keeping these notes?
Yep, these are going to be your notes. Yep. Okay, so moving down to question number 2, it says, show that each figure is a quadrilateral. So we're first going to decide for number 2 if it's a trapezoid or not. Okay, so by definition, what must be true about a trapezoid?
No sides.
Okay, so they must have at least one pair of parallel lines, right? Okay, so looking at the picture, instead of just randomly guessing and checking the slope of every single one, let's choose the ones that look like they're parallel. Okay, so which ones look parallel?
A, B, D, C.
A, B, and D, C. So let's start there and find the slopes. Okay, so I'm going to say A, B's slope, and I'm going to use the letter M to represent slope, if that's okay with you guys. Okay, so what is the slope of AB? 1/3. Everybody okay with that? It goes up 1 over 3. Okay, and from D to C, the slope is equal to up 2, 1, 2, 3, 4, 5, 6. 2, 6. So what can we say about 2, 6? That is 1/3. Okay, so now we can say since AD is parallel to BC, then you have a trapezoid. Okay, so we can say Okay, so you can say that however you want, but just make sure that you understand that you're somehow saying that a trapezoid only needs one pair of parallel sides. Okay, and we don't even need to check the other two. All we need is one pair. Okay. Everybody good on that one? Okay. Okay, so for question 3, they're now asking us to show that the figure is a parallelogram. Okay, so by definition, what must be true about a parallelogram?
2 sets.
Right. Okay, so this time we need to show that 2 of the sides are parallel to each other, 2 pairs of them. Okay, so where should we start? Yep, we're still finding slopes, yep. So what side do you want to start on? L, M, and Kn. Okay, so LM slope is equal to, everybody good with -1/2? Good there. And KN's slope is equal to, bless you, -1/2. So LM is parallel to KN. Okay, so we have at least a trapezoid at this point. Okay, so now we're going to check the other 2. So let's go from KL. What's the slope of KL? Okay, so I'm going to say, just to be show my work, yeah, 2/2, and I would agree that that is 1. Okay, and then from N to M, the slope is 2/2, which we all agree is also 1. So KL is parallel to NM. So your statement for this could be KLMN is a parallelogram because it has 2 sets of parallel lines. Okay, so that's the key piece of that. There's 2 sets. Everybody good so far? So how are you feeling at this point? Is this easy? Is this like, oh, I'm not quite there? Not quite there? Okay, so are we understanding where I'm getting slopes from? No idea. Okay, let's go back a little bit.
I don't understand.
Okay, so let's start with LM. Okay, so to go from L to get to M, you have to go down 1 and to the right 2. So since you went down, that's a negative distance, so -1/2. So that makes sense. And then so for KN, ditto, down 1/2. Right? Okay, and if I look at, let's use green, from K to L, to get from K to L, I would have to go up 2 and to the right 2, up 2/2. And from N to M, up 2/2. So it's like how you got to those spots. So that's making sense now. Okay. Is everybody okay with all those now? Finding slopes, good. Good. Okay. So continuing on, so they used a picture before, which was kind of nice. So now we're kind of doing the same thing, but now they're giving us actual numbers. Okay, we can still draw them. Okay, so this time it says find the coordinates of the missing vertex in each parallelogram. Use slope to check your answer. Okay, so I'm going to start by simply plotting the points that are given to us so we can kind of just find it like we did on the warm-up today, right? Okay, so A is 3, -3, so we're looking at right here. B is -1, -2, so right there. D is 5, -1. Okay, so the piece we're missing is what? C. Okay, so how are we going to find the C? There's two ways. Okay, perfect. Okay, so from, what did you say?
Is the slope from AD?
AD, okay, so the slope from A to D, so is up to over 2. And now where am I going to start to get that? From B. Up to over 2. Okay, so there's my point C. Is everybody okay with how we got to that spot? Okay, how else could we have done that? Okay, so we could have gone from B to A, so, well, actually, we would probably want to go from A to B, right? So you'd have to go up 1, and 1, 2, 3, 4 to the left 4. So we could have gone from D and gone up 1 and to the left 4, and still gotten that same point. Okay, so what is the ordered pair of C? Close. 1, 0. There you go. How do we do on that one? Is everybody okay with that? Okay, let's try number 5. So same thing. I'm going to start with S. So S is -3 and -1. T is -1, +1. V is 0, 0. Okay, so we're going to find U, right? Okay, so how would I get there? What's one way to get there? From S to T. So can I actually go from, yeah, T to S. T to S. So I would go down 2, left 2. Because I would want to take that from V, right? So down 2, over 2. So it'd be right there. Okay, so the other way it could have gone is what? T to V. So to get from T to V, you would go down 1 to the right 1. So where would I start that one? From S. Down 1 to the right 1. So there's my U. So what is the U spot? -2, -2. Nice. How are we doing on that? Anybody confused? Make sure you ask if you're confused. Okay. All right, so question number 6 says to show that ABCD is not a trapezoid. So if they're not a trapezoid, what are we going to show? No parallel lines. None of the slopes are the same, right? None of them. Okay, so we got to go all the way around to find the slopes. So let's go from A to B. So what's the slope from A to B? Up to over 6. 1, 2, 3, 4, 5, 6. I agree. So 2, 6, which is equivalent to 1/3. Okay, let's go from B to C next. So to get from B to C, you would have to go down 3 over 1. Good. So -3 over 1, which is equivalent to -3. Ooh, I bet that was the trick there. I don't know. C, D. So from C to D, you would have to go down to 1, 2, 3, 4, 5, 6, 7, 8. So -2, -8, right? So negative, negative. because you went to the left. So positive 1/4. And should we go A to D or D to A? A to D, doesn't matter which one. So A to D, I would have to go down 3/1 to the left one. So that would be -3/-1, which is +3, right? Because you got a negative over negative. So are any of those slopes the same? No. No slopes are the same. So A, B, C, D is not a trapezoid. Everybody good there? Okay, what about number 7? Now, number 7 says, show that the figure is a trapezoid, but not a parallelogram. So, what are we looking for if it is a trapezoid? Right, so only one set is parallel, definitely not the other ones. Okay, so let's start with which ones are parallel, which ones look parallel to you. F and G. Ah. Ooh, what's the slope from F to G? Okay, so you go up nothing, and then you go to the right 6, so 0. Good. It is 0. And then JH is also 0. Good. So we can say, yep. Show F and G are parallel to JH. Okay, and then we'll test the other one. So let's go F to J. So from F to J, you'd have to go down to 3 and right 1, so -3/1, which is a slope of -3. GH, you would have to go down 1, 2, 3, and to the right 2, so -3/2. So are those two parallel? So we would say, so FJ is not parallel to GH. So how would we say, what would our statement be? FGHJ, FGHJ is a trap because it only has one set of parallel lines. Awesome? Man, this is fun. Alright, so the next little section is determine whether each statement is always, sometimes, or never true. Okay, and then we have to explain why. Okay. So, given a quadrilateral ABCD, and it is definitely a trapezoid, and the slope of AB is 3, then for sure, the slope of CD is 3. Is that always true? Sometimes true, or never.
Sometimes, because it might not.
Perfect. Okay, so if it is a trapezoid, it is not for certain that A and B have to be the parallel sides. They could be, so it's sometimes true, But it's possible that the other two sides could be parallel. So we would say sometimes A, B, and C, D can be parallel, but, so what would the other two sides be? B, C, and DA could be parallel. Oops, parallel. Good there? Okay, so even if AB has a slope of 3, it's not certain that CD has to be 3. Could be. Okay, so what about a parallelogram has those 3 vertices and a point on the line y equals x. Okay, so I think this might be a nice one to graph since they give us points. So 0, 0, 2, 0, 0, 2. Okay, do you guys remember what the line y equals x looks like? What does it look like? It's diagonal, it goes through the origin with a slope of 1, right? So it would look like, right, like that. So that's your y equals x line. Okay, so is it for certain that if I have those 3 vertices, and we're talking about a parallelogram, that any point on xy will create a parallelogram? Is that always true? Sometimes true? Never true? Sometimes true. Which point would make that true? 2, 2. 2, 2 would make it true, but any other point on that line would not make it true. So we're going to say sometimes. So we can say 2, 2 would make a I wish there was a abbreviation for that. But any other point on y equals x would not. Okay. Number 10, if the slope of PQ is 1/3 and the slope of our S is a negative 1/3, the quadrilateral PQRS is a parallelogram. No? Never? Sometimes? What's that? Yeah, it would be never. I tried to trick you. Never. So it's a never because PQ must be parallel to RS. So they would have to be the same slope for it to be a parallelogram. Okay. If line M is parallel to line N, ooh, let's draw a picture. Here's M, and here's N, and the slope of M is greater than 1. So what does it look like if it's greater than 1? Positive, right? So it's going this way. Then the slope of N has to be greater than 1. Always? Sometimes never. Always, right? They would always be exactly the same. So if one is positive, they for surely are both positive. Always. If M is positive, then n is the same. Always. All right, number 12. Okay, so we have trapezoid JKLM with those vertices. Then the coordinates of vertex M are 2, 4. Okay, so we're going to prove if that is true or not. So I'm going to draw a picture. Maybe you guys can look at that and just know. But I'm kind of a visual learner. So J would be -4, 1. There's J. K is -3, 3. L is -1, 4. Ooh, those are close together. And M is, 2, 4. Wow, that looks good. That looks like trapezoidal. Okay, so the question is, does M have to be 2, 4? Always, sometimes, never. Okay, so let's start with, first of all, does 2, 4 actually give us a trapezoid? Okay, so if you look at that, what two sides look like they could be parallel? KL and GM. So let's just test and see if those are. So KL slope is, it's really hard to see on my graph. So I'm going to use the points if that's okay with you guys. So I'm going to use K and L. So I would go 4 minus 3 and -1 minus -3. So that would be 1/2, right? We all agree with that? Good? Okay, and then JM slope. So J to M, so now we're looking at these two. So it'd be 4 minus 1, and then 2 minus -4. So 3/6, which is 1/2. So are those parallel? Yes. Okay, so that is absolutely true. Now the question is, could M be anything else to make a trapezoid? Is there any other way you could have a trapezoid? One set of parallel lines. Asia, is there another way?
Yeah.
Yeah, there's definitely another way. Because we could make, we could put M anywhere on that slope line, right? It could just be, I mean, there's a lot of different ways. Or we could even, in fact, make LM parallel to JK and have a trapezoid, right? There's a lot of different scenarios. Okay, so this one is sometimes true. The point they gave us did create a trapezoid, but there could be a whole bunch of different possibilities. Okay, sometimes there are many other points that could make a trapezoid. Trap. How are we doing? Do we need to take a break for a quick second?
Yeah. Can I go get a drink of water?
Okay, let's take a quick break. Doing this together. Okay, so it says, explain whether the quadrilateral is either a trapezoid, parallelogram, both, or is neither. Okay, so they're giving us linear equations here. So all we're going to do is we are going to pull the slopes straight out of each of the lines and then compare and see which ones are parallel or maybe none of them are parallel. Okay, so I'm just going to start with line L. And just by looking at this, what is the slope of line L? 2. Okay, moving down to M, I hope you can do a little bit of mental math here. If you were solving for y, how would you get rid of the 2? You would divide by 2. So what's the existing value in front of the x? -1. So it'd be -1 divided by 2. -1/2. Is everybody okay with that? Can you do that mentally, or do I need to write it down?
Yeah.
You need to write it down? Okay, so this is what I did. 2y is equal to negative x plus 6 divided by 2. What? 2, the number that's in front of the x. Remember y equals mx plus b? M is the slope. The number that's in front of the x is the slope. Okay, so on line M, if I divide by 2, remember there's an existing 1 that's in front of the x. It's negative 1/2 x plus 3. So I'm only looking at that. Okay, what about n? What is the value in front of the x on it? N. 1. Very good. Okay, can you do p in your head? If you solve for y, what would you have to do with the x? Subtract it, so therefore the value in front of the x would be negative 1. Everybody okay with that? So if we look at that, do you see any that are parallel? No, none of them are parallel, so what is this shape? It's a neither shape. It creates some kind of quadrilateral, but no, it has straight edges, lines.
Probably not.
All right. What about L on number 14? What's the slope on that one?
1.
1. Letter M. What is the slope on M? Y. If we add x to the other side, what would it be? 1. Ooh, we got at least one set of parallels. Okay, can you do n in your head? Nice. I'll do it algebraically for those who cannot do it in your head. That's okay if you can. So if I was solving for y here, I would start by subtracting x. So negative x plus 6. And then divide by 2. Remember, when you divide, you have to divide every term. So negative 1/2 x plus 3. Well, is that exactly the same as before? So negative 1/2. What's the slope of p? Can I go ahead and say that 0.5 is actually negative 1/2? Because I like fractions better. So since we have 2, you don't like because they're exact. Fractions are exact. That's why I like them better.
How are fractions exact?
All fractions are exact. Not all decimals are.
How are decimals not exact?
Because what if you have 1 divided by 3? What's 1 divided by 3? As a decimal. It's 0.333333333333333. Continuing on forever. And if you told me it was 0.3, I would say, nuh-uh, it's not exact. If you give me the line, I would agree with you. What if it was, I don't know, I can't think of one off the top of my head. But anyways, I like fractions better because they're exact. So anyways, we have 2 sets of parallel lines, right? So therefore, the shape we have is a... it could be a trapezoid too, right? Because it has at least 1, so we know if it's a parallelogram, that's also a trapezoid. It's a both.
No. If there's 2 sets of parallel sides, it can't be a trapezoid. Because a trapezoid only has 1 set.
At least 1. By definition, a trapezoid has at least 1 set of parallel sides.
And this has 1 set, but it also has 2, so it could be both.
Not only 1. Okay, what about 15? Line L, can you tell me what the slope is by looking at that? 1/2, you have to divide by 2. M is 2, you'd have to subtract the 5, but that's not related to the x, so it's 2. N, 2, you'd have to add it. Oh, there's 1 set of parallel lines. What about P? Oops, equals negative. So you'd subtract the x, divide by 2. Negative 1/2 minus 3. Negative 1/2. So how many sides of parallel sides do we have?
One.
Just one, right? Only one. What? How n?
Yeah.
N is 2, because if you took this, you have to add the 2x to the other side, so it'd be y equals 2x plus 2. And the value in front of the x is just 2.
And how did you, the other one on like end of 14, how is that half?
Which one, n or p?
And
N. Okay, so what we did with this one was, so we took n, so x plus 2y equals 6. Okay, so this is my work right there, but you subtract the x, right, to solve for y.
okay.
Whoops. No. Erase. So you get 2y equals negative x plus 6, then you divide by 2, and you have to divide every term by 2. So negative 1/2 x plus 3. So the number in front of the x is negative 1/2. Okay? Okay, so 15 is what kind of shape? It is certainly a trapezoid and a trapezoid only. Okay, 16, what's the slope on L? Negative 3, because you got to subtract it, right? Remember, you have to solve for y. Subtract 3. What are you guys doing on that tablet? I'm going to guarantee it's not math.
What?
Close your tablet, please. Thank you. M, what's the slope of M? Ooh. 0, very good, because there is no x. There are 0 x's. 0. N? 3. And P? Also 0, no x on that one. So this one has one set of parallel lines, so we are looking at a trapezoid. Nice. All right, moving on. Now that I like it when we get to do algebra. Okay, so number 17 through 19, they're giving us the fact that we have parallelograms, and so we're solving for the unknowns. Number 17, we're going to start with the opposite sides and say that P is equal to 5, right? Boom. Okay, that was easy. What about Q? Okay, so if you didn't know it was 9, you would say 6 is equal to Q minus 3. So if I add 3, then Q is certainly 9. Good algebra? Okay, on 18, what two sides can I set equal to each other? Nine is equal to 3y, so can we all agree that y is 3? And what other two sides can we set equal to each other? 8 is equal to 2x plus 4, so minus 4, so 4 is equal to 2x divided by 2, and I definitely agree with you. X is 2. Okay, last one. Ooh, this is the hardest one. So what two sides can we set equal to each other? 4 w's is equal to a w plus 3. So how would I solve that one? Algebraically. So first I would subtract w, so it's 4w minus the w. 3 w's. And then divide by 3. So w is 1. Okay, then we set the other two sides equal to each other. 2z plus 1 is equal to 4z minus 5. I hate it when they use z's in math. How do I solve that one? Subtract the two z's. So we have 1 is equal to 2z minus 5, then what? Add 5 over, So you get 6 is equal to 2 z's. And lastly, so the z value is 3. Okay. Okay, now this is a really interesting, here comes a bad word, are you ready? Proof. Yep. Okay, so what they're asking us to do here is to use slope-intercept form, which, how does slope-intercept form go?
Y over.
Yeah, it goes y is equal to mx plus b. So the idea here is that we are going to prove that if two lines are parallel, then they must have the same slope. Okay, so what we're going to do is we're going to use an indirect proof to assume that the lines have different slopes and therefore intersect. Okay, does that make sense? Okay, because parallel lines by definition do not intersect, so we're going to go the other way and say these two lines intersect, so we're going to find the point of intersection. Okay, so for starters, we're going to start with our first equation, and we're going to say y is equal to m sub 1, because it has some slope that is different than the other slope, and we're going to say our y-intercept is going to be b sub 1. Okay, the second equation is going to be y is equal to m sub 2 times x plus b sub 2. Okay, so understanding that the m sub 1 value is a different number than the m sub 2, ditto with the b sub 1 and b sub 2. That makes sense there? Okay, so I'm sure that you all remember how to find where two lines intersect. Okay, so actually there's 3 ways you can graph them, but we obviously can't graph it because we have no numbers. Okay, so the second way is by substitution. Third way is by elimination. We're going to do substitution. Okay, so what did I set both of these equations equal to? Y. Okay, so if they intersect, then both of the y values must be the same. So what I'm going to do is I'm going to replace the y on the top equation with what it was equal to on the bottom equation. See what I'm saying? So I'm going to put this, I'm going to substitute this into that y right there. Okay, so when I do that, I'm left with m sub 2 x plus b sub 2 is equal to m sub 1 x plus b sub 1. Which is a pretty gnarly algebraic equation, but not too bad. Okay, what we are going to do is we are going to now solve for the x. Okay, so algebraically, if we are solving for the x, what do I want to do first? Okay, I want to get all of the x's on one side and everything else on the other side. Okay, so can I do 2 steps in one here? Can I subtract the m sub 1x and also subtract the b sub 2 all at once? Do you see what I'm saying? So subtract this one, and then also subtract that to the other side. So I'll take this one this way, and this one this way. So it'll be m sub 2 of x minus m sub 1 of x is equal to b sub 1 minus b sub 2. So those just switch sides, essentially. Everybody follow that? That was confusing? The next step is definitely awesomer. Okay, so on the next step, remember that I'm trying to isolate the x. I'm trying to get x all by itself. Okay, and I have both of the pieces with an x. So what I'm going to do is, since I have an m sub 2 times x minus an m sub 1 of x, what I'm going to do is I'm going to pull the x out like a greatest common factor. Okay, so if I pull x out, I'm left with m sub 2 minus m sub 1. The right side stays exactly the same.
Pull both x's out, or is it just...
Yep, I pulled them out of both of them, but I pulled one x out of both pieces. Right.
That's what.
Yeah, it's technically undoing the distributive property. It's exactly what we just did. Not yet. Remember, I wanted to say x equals. Okay, so my last step, if I have x times some stuff, and I want to get rid of that times some stuff, what do I do to get rid of it? You divide by the stuff, right? So I'm going to divide by the stuff. Oops, that was a bad M. Okay, so all of this algebra has just proved that the x value is b sub 1 minus b sub 2 over m sub 2 minus m sub 1. Whoops, I just dotted my 1. Awesome. What the heck did that just tell me? Why did I do that? What did it tell me, Asia? It's similar, similar in the fact that, but it would be 2's minus 1's. See how 1 is reverted on the top? It's not exactly the same, although it does look very similar. But that's not what I really care about. What was the whole point of doing this? To find the intersection point, but to initially really prove parallelity. I'm just making that word up, but you understand what I'm saying, right? Okay, so I'm thinking about the m values. Let's go back to this. What's the problem with that statement? Think about the m's and where specifically they're located.
M is M2 minus M1 instead of M1 minus M2, like B1 is subtracted from B2.
True, but that's okay. You can subtract one from the other and still get something. Okay, so you guys know the laws of math.
Which one?
Oh, I just have 10 commandments right here.
Oh.
The first one says, thou shalt not divide by 0.
There's a limit.
That's true, there is.
Plus.
I added one. The last one I added is write your answers as a fraction.
Guys,
Anyway, should I read number 1 again? Because that was really important. Thou shalt not divide by 0.
You're dividing.
How would you divide by 0?
You can't divide by zero.
You can't divide by 0. So what must be true about those m values? They have to be different. For the two lines to intersect, the slopes have to be different. Otherwise, you divide by 0. If the slopes are the same, if m2 is equal to m1, you would divide by 0, and there would be no intersection. Does that make sense? Okay, so m2 cannot equal m1. I dotted my I again. My 1s. For the two lines to intersect. That's a crazy proof. And that's a tough one to wrap your mind around because you really have to understand algebraically what's happening there. Okay, you cannot divide by 0.
Well, why is it you cannot divide by 0? Well, I know why you can't divide by 0, but what does that have to do with the slopes?
The slopes are different. Okay, so the idea here. Okay, so when we went to this first statement that I made in red. Okay, so the first statement I said, okay, we've got two straight lines,
Okay.
y equals mx plus b. And all I know is that the two lines are going to intersect.
Right.
Okay, Okay, I know they have to have different slopes, they have y-intercepts. We don't know, they could possibly be the same. We're just going to play with them. Okay, so the two lines have those two equations. Okay, so then in order to find the intercepts, the place where these intersect, I do some substitution. Okay, so I substituted that through to find the values of x. And then essentially I could find the value of y if I did find an actual number for x. Okay, but when I got to x, there was a problem. Okay, anytime you have variables that exist in the denominator, you have what are called restrictions. If I had something like 2 over x plus 3, there's a restriction happening there. What is the value that x cannot be? -3. Because if you put a value into -3, you are dividing by 0. That's a restriction. Okay, so that whole idea comes into play with that x value that we just got. We can't divide by 0. That means that m sub 2 cannot equal m sub 1. And therefore, they cannot be the same slope, which proves that if they're going to intersect, they have to have different slopes.
All right.
Does that kind of make sense? Yep. Okay. Awesome. That was a crazy proof. Okay, so this last one is actually pretty simple. Let's do it real quickly. You guys all like real world examples of stuff, right? Don't you? Okay, so it says Caitlin is planning diagonal space for the parking lot at the mall. Each space is parallel. She's already done this, and so where are we going to draw the next line that's to the right? Okay, so we're like, where is this one over here going to be? This one. Okay, so what are the two endpoints?
Two endpoints?
Yeah. Like, where are these landing? Okay, if all those are parallel. So from here to here, what's the slope?
302.
Rise over run. What happened there? 1 over 3, right? 1 over 3. 1 over 3. Okay, so from here, I would do the same and go up 1 over 3. It's still the same. Okay, so 1/3. So if I go there, what's that point? 6, 1. Okay, so if you count that out, it would land at 6, 1. Okay, ditto on this one. Since they're parallel lines, all of the slopes have to be the same. So if I'm going to start from here, I'm going to go 1/3 again. So from here, up 1 over 3, where did I land? What's that ordered pair? 5. Wait. 4, 4, 5. 4, 5. Okay? Everybody good with this stuff?